So we learned about these meta principles, and we also learned about uh, how to use them, at least in one example. But now let's come to the specific topic that we are learning, extremality. And we are going to now suggest some ways in which you can use this technique for yourself. This is what I have called it, how to smell it, how to solve it. Was there a question? Okay. So this is typically what we do. I'm now going to just state these things abstractly because you have seen some extremality examples, and then we are going to use this framework to solve the other problems that come. Okay. So we assume contrary to the question. So we have something, we are told to prove something, show something, right? Usually, typically as is in the Olympiad style, and even some puzzles are of that form. So we consider a counter example. We assume that the question's hypothesis or whatever the question is asking is false, and we consider a counter example. And we try to make local improvements in this example, right? We will emphasize what these local improvements are in the next few slides, but you should have some idea as to what I'm referring to. If not, we will see it in action again. So we try to make local improvements to the example. So we assume that the hypothesis is false. We take a counter example as a mathematical object, and we try to make some improvement to it. That improvement, of course, depends upon what the question is asking for. Then we realize that there is some parameter, there is some process in that, right? If that example is never going to satisfy the hypothesis of the question, there is some parameter, some process in that example, which seems to be going on forever. Okay, like in case of the midpoint question, it was the case that the points would keep being born, or you would have to create new points forever. If you assume that there were only finitely many points, which is really the contradiction happening. But this is how we generally think. And the moment we realize this, we understand that, okay, the way to actually show that the hypothesis is true is to take an extremal example. So what does this mean? That once you have gone through these first 3 points, you realize that that parameter or that process is what is going to be helpful. You take an example or a counter example where that parameter is maximal or minimal. Okay. And you apply the previous reasoning that led you to believe that that process goes on forever. But that would create an even more extremal example, like an even more maximal or an even more minimal example. And this is a contradiction because you started with something which was already extreme. Okay. Typically, this is what happens. And let's see it in action now.